Hello viewers, you are welcome once again. We are still under logic, Christ the Almighty, God's algebra. Today we are going to treat distribution of implication. Distribution of implication. But before then, we have two types of distribution of implication. One is distribution of implication by law. Second is distribution of implication by grace. But today we are going to treat distribution of implication by law. Let us start. Distribution of implication. Distribution of implication. Q or not P, Q upon not P or bracket not P and the P is equal to Q or bracket not P upon not P and P upon not P. This is an example of distribution of implication. We are going to prove this statement, that is distribution of implication. Q upon not P or bracket not P and P is equal to Q or bracket not P upon not P and P upon not P. If you look at this equation, you will find out that this is logical equivalent. The equation is logical equivalent. That means the two sides of the equation, they are equal. Whenever the right hand side of the equation is truth, also the left hand side of the equation is also truth. Vice versa, whenever the right hand side of the equation is false, also the left hand side of the equation is also false. If that is the case, it say it is logical equivalent and it is law because they are logical equivalent. Now let us prove this distribution of implication by law. Proof. Suppose Q upon not P or bracket not P and the P is equal to Q or bracket not P upon not P and P upon not P is our hypothesis. We say suppose Q upon not P or bracket not P and P is equal to Q or bracket P not P upon not P and P upon not P. That means it is our hypothesis. And you know that whenever the right hand side equation is true, also the left hand side equation is also true. Whenever the left hand side equation is false, also the right hand side equation is also false. If that is the case, we say that they are logical equivalent. So we are going to transform this equation to by conditional statements. See, if and only if Q upon not P or bracket not P and the P is equal to, if and only if Q or bracket not P upon not P and P upon not P is tautology being justified by logical equivalent. You will see that you have now transformed this equation into by conditional statements, and is tautology because whenever the equivalent of Q upon not P or bracket not P and P is truth, also the equivalent of Q or bracket not P upon not P and P upon not P is also truth. Also, whenever this side is false, also this side is also false. We say that in evaluation of the statement, we say it is tautology because there's no way we can obtain falsity in the evaluation of the statement. That's why he said that it is tautology because it is always truth, being justified by logical equivalent. You see, since whenever this equivalent is truth, also this equivalent also must also be truth. If that is the case, we are going to transform it into conditional statement, still maintain equivalent, still maintain truth, because this is tautology, and also when it is converted to conditional statement, it also maintain tautology. Say if and only if Q upon not P or bracket not P and P implies Q or bracket not P upon not P and P upon not P is tautology, being justified by logical implication. You see that whenever the antecedent is true, also the consequence must also be truth. In the evaluation of the statement, we say it is tautology because there is no way we can obtain falsity. That's what is tautology, being justified by logical implication. Since the statement is tautology, we say that the antecedent is logical implication of the consequence, because it is certain that Q upon not P or bracket P and P is certain. It exists because the statement is tautology. There's no possibility of ascertaining falsity in the statement. That's why we say that the accident is certain. That means it is logical implication of the consequence. You say if and only if Q upon not P or bracket not P and P is logical implication of Q or bracket not P upon not P and P upon not P. So we say that Q upon not P or bracket not P and P is logical implication of Q or bracket not P upon not P and P upon not P. That means the consequence is logical implication. The implication, the accident is logical implication of the consequence. Since not P, since Q upon not P or bracket not P and the P is logical implication of Q or bracket not P upon not P and P upon not P is certain, we say that if and only if Q upon not P or bracket not P and the P is equal to Q upon not P or bracket not P and the P being justified by identity. Being justified by identity. You can see that the consequence we derive as logical implication of the consequence is now equal to and it is truth that it is equal to itself. That means Q upon not P or bracket not P and P is equal to Q upon not P or bracket not P and the P. Being justified by identity because that means they are the same. So whenever the other side is truth, also the other side is also truth. Whenever the other side is false, the other side is also false. We say that it is law. Being justified by identity, that the sameness. You say if and only if Q upon not P or bracket not P and the P is equal to Q upon not P or not P and bracket Q upon not P or P. We have seen that this Q upon not P is being distributed among or between P, not P and the P. That's why we have this Q upon not P, or this not P. Bring down and connective bracket this Q upon not P, or is distributed to this P. You have Q upon not P or the P. Being justified by law of distribution. Law of distribution still maintain logical equivalence. Still maintain logical equivalence. So it is still law. If and only if Q upon not P or bracket not P and the P is equal to. Now let us convert this Q upon not P that is in conditional statement, because this Q upon not P is a conditional statement that is in this form. So you want to transform it to its logical equivalent in the disjunctive statement. It will be bracket Q or P bracket or not P close bracket and bracket. Now the equivalent of Q upon not P also in the disjunctive statement is Q or P or bring down the P in close bracket. Now you have now transformed this Q upon not P here to its equivalent in disjunctive statement, and also this one also to disjunctive statement. Being justified by first case law, because it being transformed by first case law to disjunctive statement by first case law. Say if and only if Q upon not P or bracket not P and the P is equal to. Now let us associate this P and not P, because we can associate P and the not P still maintain equivalence. You still preserve a equivalence. That means you are going to have Q or bracket P or not P, and the same thing, let us associate this P and the P. We have Q or bracket P or P. Being justified by law of associativity. Say if and only if you see that you have Q or and also Q or here. So by law of distribution, we are going to bring Q or out. That means I'm going to have Q upon not P or bracket not P and the P is equal to Q or bracket P or not P and bracket P or P. P or P is still preserve equivalent being justified by law of distribution. Law of distribution. Let's continue here. If and only if Q upon not P or bracket not P and the P is equal to Q or now let us transform this P or not P into conditional statement and also this P or P also into conditional statement. The is equivalent into conditional statement. We are going to have Q bracket P upon not P. Because you see that P or not P is homology and not P implies not P is also tautology. That means not P upon not P is also tautology. And we have P or P is P. We're going to have P upon not P, which is written as P. P upon not P, that means P implies not P is P. Is P being justified by first Ejike's law. By first Ejike's law. You have found out that we have now proved the statement that Q upon not P or bracket not P and P is equal to Q or bracket not P upon not P and P upon not P. He sent him as this. So you have proved it. He said thus Q upon not P or bracket not P and the P is equal to Q or bracket not P upon not P and P upon not P. They are, it is distribution of implication by law because they are logical equivalent. Now, since it is law, we are going to prove the converse. Since it is law, we are going to prove the converse to show that it is equivalent. You say conversely, suppose Q or bracket not P upon not P and P upon not P is equal to Q upon not P, or bracket not P and P. Suppose that Q or bracket not P upon not P and P upon not P is equal to Q upon not P or bracket not P and P is our hypothesis. We assume that they are equal, but it is the converse. It is the converse. Since it is converse, we know that whenever this side is truth, also this side is also truth. Whenever this side is false, also this side is also false. If that's the case, say that it is logical equivalent. We say that if and only if Q of Q or bracket not P upon not P and P upon not P, if and only if Q upon not P or bracket not P and P is tautology. We say is tautology. That means whenever this equivalent is truth, also this equivalent is also truth. Whenever this equivalent is false, also this equivalent also must also be false. That is the case. We say by conditional statement, it is tautology, because in the evaluation of this statement, there's no way we can obtain falsity, always truth. That's why we say it is tautology. Being justified by logical equivalent. Being justified by logical equivalent. Let's continue to this side. Since you have now transformed this to conditional statement, you see that whenever this Q or this equivalent is truth, also this equivalent also must also be truth. Now in that case, we can transform it to conditional statement, still preserve equivalent of tautology. Say if and only if Q or bracket not P upon not P, P upon not P and P upon not P is equal to implies Q or bracket not P upon not P and P upon not P implies Q upon not P or bracket not P and P is tautology, being justified by logical biological implication. Being justified by logical implication. You will see that it has not transformed to conditional statement, still preserve tautology. That means whenever the antecedent is truth, also the consequent must also be truth. In that case, say that it is tautology, because there's no way you can evaluate the statement to be falsity. Always truth. You say it's tautology. Being justified by logical implication. Say if and only if Q or bracket not P upon not P and P upon not P is logical implication of Q or not P or bracket not P and P. You have now derived that Q, you have now derived that Q or not P upon not P and P upon not P is logical implication of the consequent Q of the consequent of Q upon not P or bracket not P and the P. That means since the evaluation of the statement is always truth, that means that it is certain that the accident exists. In that case, say that it is logical implication of the consequent. So it's certain that accident exists. If that is the case, you say that if and only if Q or bracket not P upon not P and P upon not P is equal to Q or bracket not P upon not P and P upon not P. P upon not P being justified by identity. We can see that the logical implication is equal to itself. That means it's equal to itself by law. So it is logical equivalent because whenever the other side is truth, the other side is also truth. When the other side is false, the other side is also false. So it's logical equivalent. So be justified by identity, that means the sameness. He said if and only if Q or bracket not P upon not P and the P upon not P is equal to, let us distribute this Q to between P upon not P and P upon not P. We have Q or Q or not P upon not P and Q bracket or P upon not P being justified by law of distribution is still preserved equivalent. by law of distribution. Say if and only if Q or bracket not P upon not P and P upon not P is equal to. Now let us transform this not P upon not P into its logical equivalent in disjunctive statement. It will give us Q or bracket not P bracket P or not P, and also this one transform it is equivalent to disjunctive statement through first Ejike's law. We are going to have Q or bracket P or P. So being justified by first Ejike's law. So consider this side. We say that if and only if Q or bracket not P upon not P and P upon not P is equal to, let's associate this Q or this P. We have Q or P or not P. And I should take these two, bring down, and then bring down or not P. And let us say this Q or P. We have Q or P, or you bring down or P, being justified by law of associativity, by law of associativity, still preserve equivalence, still preserve logical equivalence. We continue, say if and only if Q or bracket not P upon not P and P upon not P is equal to, let's transform this one into, or you see that not Q or P, Q or P also, they are common among this, between this, between the conjuncts, between the conjuncts. So you bring it out. You have Q or P bracket not Q or P or bracket not P and the P, being justified by law of distribution, by law of distribution. He said if and only if Q or bracket not P upon not P and P upon not P is equal to, transform this one to, transform it to conditional statement by first education law. We have Q upon not P, or bracket not P and the P, being multiplied by first education law. We have seen that we have proved the converse. That means this equal to this. We have proved the converse. That means it is law of distribution. By converse, it's also equivalent to each other. We then say thus Q, or bracket not P upon not P and P upon not P is equal to Q upon not P, or bracket not P and the P. So it is equal to each other by converse. We then conclude that the distribution of implication exists. We said therefore Q upon not P, or bracket not P and the P is equal to Q, or bracket not P upon not P and P upon not P is distribution of implication. Now we have now proved that distribution of implication is truth. So by the extensionality, it is truth, because I have now proved, you have already proved the converse. So at this junction, we will draw our curtain. Thank you, viewers.